the recording on and we'll just talk into it. There will be nothing on the screen to look at, but it'll capture it in case you want to go over it again. Have your paperwork for the project and just a pen and paper. AT2. AT2. Yep, class 2. We'll do AT3 tomorrow morning. So let me forget, tomorrow morning, Despina, we've got to finish off a couple of NCC clauses for AT3 that we didn't quite get finished.
Okay, yep.
Now I've said for you to remind me, I'll probably remember.
Okay.
Just in case.
Yeah.
Yep, you get it. Make yourself at home. Our little design bench should be big enough for all of us. Yeah, it's lovely. I much prefer this than standing up the front all the time. Part of the reason why we launch into projects so soon is simply so that we don't spend the entire year with me standing up the front doing exactly what I've been doing for the last however many days. Normal chair. Comfort. So these drawings look very much like preliminary sketches, really lacking in precision and just giving an indication of the proportions, a bit like when we were trying to teach ourselves to sketch to scale. This might be the kind of preliminary sketch that an architect might be able to produce. Got enough room to shift along a bit? Yeah, come a bit closer. Yeah, everybody got a bit of room? Lovely, very cozy. So these drawings in your set have some preliminary ideas of where everything might go and a bit of an idea of how that might work with the street and a bit of existing blockwork noted from the site behind. Early stuff. Then somebody like yourselves would get given that sketch perhaps, might even be more rough than that and less detailed, and be asked to produce a model in Revit that could be shown to the client to give them a bit of an idea of how their different plan views could look in 3 dimensions. And then that would give you the opportunity to create something that painted a bit bigger picture, a bit better picture to the client of what they might be getting. So that might be something that you could give them as a result. There's just some indications of what the construction might be. There's just some indications of what some of the finishes might be. It's very early preliminary design. And then once you have this kind of information, you can start comparing it to the regulations like you have been. So it's very preliminary and up for a lot of changes. But having that 3-dimensional view lets the client know that we're agreeing with their vision and their budget.
Yeah. Really different concept. It's open to lots of changes at this stage. Lots of ideas need to be figured out still.
This kind of illustration is more likely to be something that you would use for marketing purposes or the planning submission. The colour coding, upside down. The colour coding is really helpful. You can have tables that illustrate living area totals and balcony area totals, and that can be really useful for both marketing to the public and for the planning department as well. So colour isn't shown as much in working drawings, but in planning submissions, it's very useful. Planning submissions aren't always just for planners, they might be for the public as well. Big projects like that go on to public display, so they need to be readable by the general public who aren't typically familiar with the way drawings work, so they wouldn't necessarily be able to do all the calculations themselves, so you'd spell it out. And then we move on to something that would be a bit more refined. Now this would be the stage where you would take what was perhaps just a 2-dimensional sketch handed to you from within a meeting like this, so the client and their group and the design team and their group might sit together around a table like this and discuss the brief initially, and the architect might sketch during that conversation if they're so inspired, but then later on they might form up a more specific initial sketch and ask you as the designer to put that into 3 dimensions in Revit. And then once it's gone back and forth a couple of times within the team, then you can start to refine it a little further and get to details that can really be checked and compared to the NCC. So we've done a lot of work already about how the construction will come together to be compliant with the rules and regulations. But we've also got some decisions to make about how that structure might look. We've decided where it will go, but we also need to know how it's going to get off the ground. So in Revit, you can do just massing, but we could also choose particular systems. So let's have a bit of a look. I always work from the ground up when it comes to construction systems. I've never found it to be helpful to work any other way, so that's generally where we'll go if that suits you. Now, what do we know about the foundation, the site, the location of where the footings will go? Whereabouts is this address again? Margaret Street. Yeah. And can you remember what soil classification we were dealing with?
S-type.
S-type construction, S-type site class. And what does that stand for again?
Slightly reactive.
Correct. So clay type soils. So slightly reactive. So quite stable. Very, very good site for our uses. And is it a sloped site or is it predominantly flat? Do you remember?
Predominantly flat.
Yeah. And is there any vegetation on the site?
Rocks and
no vegetation.
No.
there's rock.
That's your coffee area.
Vegetation.
That's certain rock.
The coffee rock? Yep,
Yeah,
yep. So there's a chance that should we dig down, we might discover some rock. So that might mean blasting to remove it, depending on how far down it is. So definitely need a geotechnical report to be able to determine how far down that rock might be and what the consequences of that might be. We're not digging a big excavation, we're not digging a big basement in the ground or anything like that. We simply want some footings to sit on that soil. Does anybody want to perhaps have a suggestion of the different types of footings that we might need for, this is our lowest level for our car park, and keep in mind that we do have, you can already see, multiple stories, so there's a fair bit of heavyweight construction coming down. Does anybody want to have a bit of an idea? We've got some indications of locations of what looks to be columns already laid out in the construction system. What will they need to be sitting on?
Depending on the geotech thing, we might have to put some piles maybe on the softer soil.
Okay.
Like that. Coming back from the chair.
Yes. And what else could we use? If the geotechnical report is reasonably positive, we've got a Class S site already, so we already know it's reasonably stable. But we also know that this is heavyweight construction and there's quite a bit of it. And these are quite specific points, these columns. What do you think the footing might be that's best on fairly stable soil under significant loading in several points? What's the best footing for those columns?
I'll go with piles or columns.
One says piles.
Sorry,
Anyone?
column.
We've got a column coming down.
Yeah, we've got the column, so I'm just
to
wondering about the
the
footing.
point.
Yeah.
Leave it there.
Yeah, pad footing. Anybody want to take a guess at anything else?
Waffle is usually common just for houses, yeah, residential.
You can use the waffle slab, so we're just talking footings at the moment, but
Yeah.
the slab itself
I know
could be
what you're
waffle.
saying.
Yeah. Oh, you think so? So, can you describe that with the vocabulary? So this is the column.
Column and the plate.
Pad.
Pad.
P-A-D, pad footing. And then,
Is the rock, some steel rock?
yeah, or the Cassian piles that were earlier in the day. Yeah. So it's a bit of a combination between the three, isn't it? it does very much depend on the geotechnical engineer. I think you're all right. I suspect the S-class stability, it's flat, unlikely to be inundated with water. It's not in a flood zone, and it's Class S site, so perhaps the pad footing would be the likely outcome. So we could mention this, should it be necessary. Suggest that perhaps the pad footing is most likely.
I remember what Lisa said about when you're suggesting something to the engineer, because remember that you're going to draw this first and then the engineer's going to look at your drawings. We probably want to draw the least expensive type of construction.
What we'd really like is pad footing.
It should be pad footing, so that's the simplest and easiest, and we think it's, only it's S-type, slightly reactive, we think we get away with the pad, and so that's what I personally, and Lisa think too, would draw. And if the engineer decided we needed the piles because the geotech report came back, or we needed the Cassian style pad with the anchors coming down like you suggested, then I think I would leave that to the engineer to suggest.
Agree.
I would just go with pad.
We can't really know what size. They're going to be quite substantial. They'll be a lot wider than the column and quite deep, but we can't really know. And they won't all necessarily be the same. So depending on where the geotechnical analysis is done, if there's an identification that there's just a weak spot, then the footing might be different in just that place. So we can't really know that without speaking to an engineer. So we're happy to specify the pad footings. Don't forget to note that they will be reinforced. So at its lowest point, this building has reinforced concrete pad footings. Look at that, beautiful. So we've already talked about these columns. What would they be constructed out of, do you think? It's as obvious as it sounds. What kind of concrete? Reinforced concrete. Excellent. So the next level up in that place will be the reinforced concrete columns. Now, does it look to you like this 800 measurement is for the columns? You see that there? But there's a proposal that those columns might already be known. We've got these 250 millimetre wide, 800 millimetre deep column dimensions, I think. And that would have to be checked and confirmed by the engineer. What else have we got happening on this ground floor level?
Comment on the columns there.
Yeah.
So a little bit of the work has already been done here for us, but remember that you're the building designer, and the structural engineer, while he's very concerned about the columns and where they're going to go, he's not concerned about car parking. Can you see the integration on that plan of where the columns are and where the car parks are? So if your structural engineer comes back to you and says, I would like those columns to be at 4.5 metres centre, 4.5 metres centre, that's not going to work in with the 5 metres that you've got clear space for 2 car parks there. Remember, your car park is 2.5 metres wide, so you want to be able to try and get your 2 car parks in between each column. That's already there, but remember, if you're the person, if you're coming up with the concept design, you may not know the locations of those columns. So consideration in column location is how does the function of the building, in this case the car park, work with the locations of the columns. Remember, you get to suggest where they go first before the structural engineer does his work. So obviously, if you can show him a car park layout and show him that you've allowed for a column location, but you require the 5 metre centre, sorry, 5 metre clear. 5 metre centre.
Close enough. What else have we got going on this ground floor level? What other construction are we likely to see? Yeah, there's some walls, isn't there? Yeah. Before the walls. Slab, yeah. Some floor, yeah. So the walls have to sit on something. Well, how many slabs have we got here? What have we got going on? What kind of surface would our driveway and car park be on, do you think?
Or polished concrete.
Oh, goodness. That's very expensive. Concrete, yes. Screed finish only. Sorry. Economical, remember, our clients got made of money. Yeah, it could be, but it isn't. Alva's not that rich. So, concrete slab. Now, where will the extent of that slab be? The whole site? Where can you find perhaps where it might go?
Not sure where the undercolor is.
There's a bit of a line here, isn't there? That might be the extent of the slab that the cars will be trafficking on, because we might need to treat that one differently than the rest, mightn't we? It might move differently under greater loading than perhaps the footpath might, or the area around the barbecue or the garden, where it's just
the
people.
Loads are different.
Yeah.
The loads would be different because you've got traffic loads, and then you've really in a separate instance the barbecue area. We have to determine whether the barbecue area is going to be a hard surface. Do we want it to have a floor? Where do we want to extend the floor to? Around the pool and the garden area. And also what pedestrian pathways are you going? There's quite a lot of concrete to consider on this.
And concrete's a reasonably good, it's got longevity, it's easy to maintain, it's easy to look after. It has a good return of investment, if you like. So it's a good choice for these surfaces. Pavers that might create trip hazards through movement don't seem like a very good long-term solution. Polished concrete's a little bit expensive. Painted concrete isn't as hard-wearing as I might like. You can put an oxide in concrete. It's a coloured powder that you can use to tint concrete. That's quite popular. We talked about exposed aggregate and pebblecrete the other day. Again, quite expensive for this kind of moderate economical investment. Any suggestions on the composition of the concrete? Do we want to nominate anything special out of all of that stuff that I just mentioned? I'm just thinking about the finish at the moment.
Let's deal with the car park first.
Yeah.
The car park slab. What do we want the finish to be? What do you see? When you drive into most apartment buildings, what do you see? Exposed concrete.
It's just standard concrete, isn't it? Yep. So we're going to have a slab specifically for the trafficable car park slab. So you might want to note that, car park concrete slab. You're probably only looking at a standard 100mm thick slab for this, but it will require a thickened edge like most external slabs do. That'll probably be 200mm thick. So a standard trafficable slab is a 200 by 200 thickened edge footing on a 100 thick concrete slab. And you will want to include a little sketch of that edge in your report. You're going to need that fabric reinforcement in the slab itself, but not in the edge beam, because it's not supporting any walls. There's no requirement to have reinforcing in the edge beam. Probably just put the fabric in the slab itself and use the concrete to do the stability on the edges. This is a very big expanse of concrete. What's the big issue with such a big expanse of concrete?
Cracks.
Precisely.
Put construction joints in certain areas.
We are. It is going to require construction joints. Remember that cut that we were talking about that you specifically put in the concrete at certain intervals? If you had to guess, would there be an obvious place for some of those construction joints? Or would you leave it up to the engineer maybe? Maybe a little bit of both? You definitely want to reference the fact that construction joints are going to be needed for the report. It's not necessarily something you might do in real life back to a design team, but I want to see that you know that this kind of construction needs construction joints included. And a little sketch of that to show how that would look would be fantastic. Just a little detail sketch. It's very common to put construction joints in long span concrete. Footpaths have it, garage floors have it. Very straightforward construction.
I remember when we talked about the construction joint, we talked specifically about the weakest part of the concrete slab, which is these internal corners like this are very weak.
Yeah.
So you would certainly be having some reinforcing here in your slab, but you probably want to take some construction joints off that line. It's obvious that I can see on the plan there for them in right now.
That's a good idea.
You'll have another internal corner.
Yeah, we've got a couple where it changes.
Yeah.
Yep. They're called re-entrants. Excellent.
In a way, the different compositions of concrete changes from from the driveway to the where the parking, so I'm guessing along the edges, yeah?
That's not an edge. It comes right out the back. So
okay.
you don't. There's no lip or anything where the cars. It's all one piece. But
So
yeah.
I'm saying like the barbecue area and then the driveway.
Yeah, between the two it would be different. Yeah, that would be a different slab.
Yeah.
And it would have that foam between it that we talked about.
Yeah.
Yeah. So we've got a few other things happening on the site. Sandra mentioned the barbecue area and the garden and the pool. And you can see there's a bit of a fence out the front, and there's a electrical easement, I believe, or an area for a transmitter just out the front. Yeah, so that's fenced off. Yep. And then we've got booster pumps and fire hydrant valves and all sorts of different types of safety and fire services out the front. So we're screening that from the view of the internal leisure space. And then we've got the driveway access here, and that'll be crossed over the verge. And then we've got this bin enclosure where the rubbish can be kept. It's convenient for collection. Typically in apartment complexes, the council get out and collect the rubbish for you. You don't have to wheel it from here to the verge and have it be collected like you might in Class 1 residential zone. And then there's access as well. So we don't necessarily want pedestrians walking on the driveway to get in. It doesn't seem like a very smart idea. So we've got them sort of this little side entrance, and there's probably, you're looking at maybe security so that only people who are entitled to get access here can get access. It's a little gate of some sort, a locking mechanism. You can see a swing there. And then this looks to be like access way here, all the way in down the back to both either the stairs or the lift up. It's not one of those fancy apartments where you have a grand entrance right on the street and the cars are around the back and down. That can be a configuration that apartments often have where you can't get any further. There might be a door person there or just security or something like that. This is a little less fancy, but it does give you the access to the lift and the stairs at the back there. So there might be another security entrance just here. And then we've got access through the car park and down into the barbecue and the leisure area here. So we talked about surfacing in the barbecue area. This is likely to be porous. Thinking about the planning, what do we need to have on the ground floor for planning? Do you remember?
No. There's I think it was 30% grass or
landscaping. Yep. Do you remember that? Do you remember that, Nicole? Where we had to have and what was the 15%?
Is that total area?
Communal. Open
space.
Open space. Yeah. And it had to be impervious. It couldn't be sealed up. It needs to have planting and landscaping, things like that. So we've got landscaping around the outside, perhaps to create some scenery, but this is our main landscaping area, isn't it? So we can't concrete all of that, but perhaps the barbecue area could be included in part of that, and we would perhaps surface that. So it needs to be water resistant because we've got the pool right nearby. People are going to be, you know, outside and water and splashing and rain and all the rest of it. So it'll probably need to be drained and falled and everything. But that'll be a slab there, won't it? So a concrete slab for the barbecue area, the bin enclosure, and there's also these little storerooms at the back, isn't there? So separate slab for those three, and the footpath going to it. So the barbecue area slab could be finished in lots of different ways. Anybody want to suggest a way that we could propose to finish the barbecue area slab? We could probably upgrade from just plain concrete a little. Exposed aggregate, yeah. It's a bit uncomfortable underfoot, and this would be a barefoot kind of area, but that's not a bad idea. What do you think, Nicole? Sharon, sorry. Anybody any suggestions? Tiles? So what kind of tiles are you thinking? Okay. So
whether they're like porcelain
yeah, so there's porcelain and ceramic. So you can get both in non-slip, but that would be the most important factor, is they'd have to be non-slip tiles.
Yeah.
Ceramic is typically the same material all the way through, whereas porcelain is typically mostly concrete with a very thin veneer of porcelain on the top. It's quite expensive and it can be a bit fragile, so the concrete gives it some strength. Both would look really good. Porcelain is terrific because you get this really lovely crisp edge on your porcelain tile, whereas a ceramic tile has a bit of a curve because it's a liquid and you get a meniscus on the edge. But porcelain can be cut to shape and glued on top, and it's really, really sharp and precise. It can be really quite a stylish finish. So non-slip porcelain tiles would be terrific. But there's other options. You could have the exposed aggregate or the pebblecrete.
What about that? What do you suggest, the iron oxide, whatever, to stain the concrete?
The oxide colouring of the concrete. Yeah, that's actually a really nice idea. Unfortunately, some of the colours just aren't very nice. So half-strength black is really good to get a grey, but it heats up so much. It's exposed, and I'm just worried that that's not wise. So I'm thinking that perhaps the tile finish might be ideal. It can't be the kind of place where there can be an impact because they might crack. You don't want things to be dropped on them, but I think we're fairly safe. You'd have to have like something really heavy to drop on to break them.
The barbecue area, obviously there's going to be like oil splatter, so you don't want oil stain on the concrete as well.
Yeah.
So
Any texture is going to hold that oil, and porcelain won't hold it. You're right.
So
It'll be easier to clean off. Good thinking. All right, so porcelain tile finish in the barbecue area.
Okay.
And the bin enclosure, the footpath, and the area under the store. We'll give them porcelain tiles too.
Too expensive for that area.
Be a bit fancy, wouldn't it? Yeah. The fanciest bin enclosure in town. We don't want that, do we? So just the standard concrete for the bin enclosure. Perhaps the standard concrete for the footpath and the stain under the storerooms as well.
Yeah.
Could get the concrete and the footpath with pedestrians, a little bit of that.
Yeah, bit of something.
We've already brought them around the back of the building.
Yeah, we're already struggling with them. It's a bit rough, isn't it?
Concrete as well.
We'll use lighting to jazz it up, okay? We'll have some pretty lights.
What about those, you know how they can put those stencils over concrete and then put the iron oxide on it?
Yeah.
Can I do that?
Nope.
Okay.
It looks like a stencil.
Okay.
Yeah.
What about that pebble creek on the footpath?
The pebblecrete is nice. Yeah, that can be an option if you like.
And
It's not
it
too
has that
expensive.
advantage of being non-slip, which is
It does.
good.
Yes. Yeah. Pebblecrete. Yeah. No, Crete. C-R-E-T-E. Pebblecrete, all one word. So we've got a little structure next to the barbecue area for either an ablution or the pool pump or something. I'm not entirely sure yet. I don't think it's an ablution, but could be. It could be the intention. Whether it stays looking like that or not is another thing. I probably wouldn't advise it. Yeah, the little structure there.
Isn't that the toilet?
Yeah.
That's what we're just saying. So it could be ablution is the word for that. Yep.
Okay, outdoor toilet ablution.
So there might be, it might need to be bigger and, is it?
When I first came here, I didn't know what people were talking about.
Oh, really? Okay.
What is that?
I'm going off to do my ablutions.
To me, ablution.
It can be.
I was mixing it up with, the toilet.
Yep, yep.
You know this word?
No, you do now. Yeah. Well done. Good on you. Well spotted. And then we've got just 3 storage areas, so not everybody gest one, but first in, best dressed. I predict there'd probably be just the ground floor people get it. I have no idea.
Ground floor storage, yeah.
The one bedroom.
Ah, wow. Good to thinking. You're probably right. So a little bit of storage for, yes, probably the biggest storage. You're right.
The other ones, some of the units had storage. The other ones didn't.
That's true.
Yeah, yep. Well spotted.
And this one showed that quite
Yeah. And that one doesn't have any
The
storage.
pink, yeah, pink store, so stores for that one. Well spotted, and there's only 3 of those, that's who it's for. There you go. And make a note in your report that the storage is for the 2-bedroom units. Well done. Good sleuthing. So what construction are we proposing for those areas? We've got a bit of walling here by the barbecue area. It's probably a place to fix some services and also to have a bit of protection, say if the barbecue goes up against that wall. We've got the fencing out the front, the bin enclosure that's open, the storage areas that are up underneath the slab, the lift itself. What's all that construction likely to be made out of? I kind of mentioned it already.
What are options for the construction?
Masonry.
I've been
Reinforced blockwork.
Blockwork, yeah.
Yeah.
Load-bearing blockwork.
Yeah.
What's the other option? We haven't decided what the structure is going to be. What could possibly be?
Precast concrete, but it's unlikely.
But it is an option.
It is an option, yeah. What else? Andy, can you think of any other?
I'm just thinking block.
You're thinking blockwork? What other typical construction do we use here in Darwin? So there's concrete and the other one? Yep, steel framing.
Steel frame.
Yeah. So there's no reason why we couldn't just create steel frames in these spaces and then clad them with perhaps a CFC product, concrete fibre cement sheet that's water resistant, and then we could seal it so that it's waterproof.
And aesthetically, that will look exactly the same as a rendered blockwork wall. The finish would be exactly the same. So we get a couple of options there. It's likely that we'll probably copy the same construction that we're using for the remainder of the building. To change construction for one small part is unlikely. And
so
it also means you need 2 different trades on site. You need steel workers and you need the block layers. So we'll probably stick with one of those trades. We tend not to mix them up too much. The other thing is if this was a steel frame construction, I only see these columns coming down in these locations. If these walls were built with a steel frame construction, that steel frame construction would be highly unlikely that it was supporting the slab over me. So I would probably suspect that I would be seeing some more concrete columns perhaps in this location, maybe another one out here, depending on where that overhang comes to here, doesn't it? You've got the columns all the way here, but it appears to me that where this walls are currently located, you see there's a little column in there, even within the wall, that I would need more columns if this wasn't load bearing.
So we're using the blockwork on the ground floor to support the first slab.
I think wasn't that a preference of the client as well? You mentioned that.
Just nice, simple, basic construction.
I think it's so that there's a nice
Yeah.
We can establish then that our ground floor walls are load-bearing blockwork. Is that agreed?
Reinforced blockwork load-bearing walls on the ground floor. we talked a bit about the point load between the first slab and the top of the columns supporting it. Might we recommend something at the top of those columns? Between the top of these columns and the first slab sitting on it? Yeah. Yep, that's it exactly. A capital. That's still not the word I'm trying to remember, but it'll do. So I would perhaps suggest that maybe just a pad, just an extra, what did they call it when the slab came down a little bit? There was a word for it on the screen, I forget now what it was, but perhaps just a big square around the top of the column. That might be something that we need to consider. And we have the opportunity to create the height we need. Did we already decide what height we were going to have? I have a note on my drawings, but I'm not sure if we actually decided together. No. Yeah, we did. Do we want to just perhaps hit on a height for the columns? I don't think we did.
Because there was like, is it 28 meters?
The overall?
Yeah.
So we talked about them.
The rules change or anything above rock height and that.
25 is where it changes, yeah. So we don't quite reach that because we've only got the 3 stories of approximately 3 meters each. Yeah.
I think they have something.
What's the planning scheme limit for our overall height? Do you remember? I don't think they had an overall height. It was just the density in the stories, wasn't it? So we're okay with that. Does anybody want to throw a dimension out there just to see what we think? How high should the columns on the ground floor be? 4 meters here, Sharon suggests. I like the sound of that. Because we've got to cover any type of car that's going to come down. There's no slopes or anything. We're not looking at any movement in levels, but we do have to account for
services.
The ducting and the services. We've not got ducted air conditioning, but we will have plumbing underneath the slab. Yeah. So it's not a huge amount of space, but we need some.
4 or 5?
5 might be a bit excessive, but
4 meters should be sufficient.
4's plenty, I think. Yeah. We could probably go a bit.
Do you think the higher or lower than your living space?
Definitely higher. Well, for my one is because there's heaps of 4 drives that go underneath there, and people stop. And it's even stripped some. I live in an apartment that's got underground car park, and there's boats even in there. Yeah. Okay. And some boats
can be quite tall. Yeah. Caravans and things. Any takers on 4 meters? That's Sharon's suggestion.
Let's put some bets in.
I'm happy. I went into a shopping centre car park that had very unusual construction, and I actually had to stop and try and estimate. It was 7 meters high. It was extraordinary. It was so bizarre being under there. It was just a weird shopping centre that had a strange fall, and it wasn't 7 meters everywhere, but in this one place where I parked, it was very, very tall. It's doable, but it was strange.
You know when you drive into Casuarina and you've got the overhead signs outside, the clearance height? Typically they say a clearance height of about 2.5. That's generally what they're thinking along that scale. But that's when they're trying, in big shopping centres, trying to fit loads of cars in and lots of loads of cars in. And multi-story car park.
The Smith Street car park is 2.7.
2.7, yeah. Okay. Yeah. And then that's the clearance height. That's
the clearance height.
To the underside of the slab. That's the clearance height to any services.
Because they've got sprinklers and signage and lighting and directions.
Lintel that's over the entrance.
Where the beams come down, that takes away some of the clearance.
Yeah. That's what I'm saying, colours are generally 2.5 high, but that could be their clearance.
We might say 4 metres to the underside of the slab above, but that's not the clearance.
Yeah.
How does that sound?
Yeah.
All right. So 4 metres to the underside of the first slab. And then that'll probably give away maybe 800 millimetres to beams and recesses and plumbing and services and sprinklers. No sprinklers. Yeah. That'll save us plenty of room.
So 4 metres
to the underside of the first slab. So on our elevations, there's some levels. They're just labelled. There's no dimensions on them. You could perhaps put 4,000 adjacent to that. Thankfully, Sharon picked one figure that I was hoping for, that I've already written down. Well done. So you could perhaps just indicate that. That's not the case for the rest of the levels. That's just a special one for the ground floor because the standard wall heights will come into play for the other levels. Like that?
Level 1, this is to be, if this is 0 at this point, you're going to be up to 4 meters at this level here.
You see that? Just there? Oh, you've got it. Lovely. Yep. Good on you. All right. So we'll probably have rendering finish on these walls, do you think? We're not going to leave the walls exposed and painted, the patterns. They'd have to be sealed and waterproofed, but are we going to cover over the pattern of the blockwork, or are we going to leave it exposed like the wall at the end of the classroom?
There are living areas, and it doesn't have to be that pretty.
It's got porcelain tiles, remember? Let's lift it a little, just a little.
For external, I would say yes.
Not for internal. So inside the storeroom.
Yeah, yeah.
That's fair.
And perhaps, you know, you could even go so far as to say, really, we don't really need to do, we could have blockwork on this side.
On the inside of the car park. Yes. They're only going to make a mess of it anyway.
Recreational area, it's meant to be inviting for people to use.
This is our input, Miss Designer.
We're all designers here. Don't pigeon. No pigeonholing. Designer. Cars might back into that wall and it'll just make the rendering chip off. Yeah, so we keep the internal car park walling sealed, that bare face, and then...
And it's probably a little trick of designers and something like that. We tend to do, you know, probably this wall, the outside of this wall, as is the entrance as you're driving in. We would have a nice finish on that, you know. We'll just forget about you once you go around the corner here.
Yep.
You can look at whatever.
Out of the line of sight.
As long as we can see from the street, we've got to remember it's going to have to sell these apartments and it's going to have a little bit of an enhanced appeal.
Mm-hmm. You can get a render that's quite hard wearing, and it's called a scratch coat, and it's got like little lines in it that gives a bit of texture, so you don't have to have perfect finish. It just allows for some imperfection, and it's built in. The size of the sand in the render, as you scratch it, creates little holes, just little pivots. Scratch coat.
Is that when they put like that
Room.
on the
Oh no.
wall? Because at my house when we were building it, I saw them do the outside of it, and they chuck like the clay or like it's not a clay, but it's like
A mud. Yeah, the render.
And they get like the flat, you know. Is that what it's called?
Yep.
So I'm trying to figure what it's called.
Yeah, it's called scratch coat. Yeah.
Scratch coat. Okay, I remember
Scratch coat. Yeah. Because it creates scratches in it as you coat.
Okay, well that makes sense.
Yeah. And the bigger the sand.
Where they throw with that.
Yeah.
Pebbles in it, which is called like a pebble dash. It's not that.
That's different.
Even
Yeah.
tougher.
It's really.
Yeah, that's really.
And it catches the dirt, does.
Yeah.
And I've had internal rendering that's got like big round, you know, swatches in it. It's awful. Catches all the dirt.
Like fashionable in the 80s, still
yeah.
my dad re-rendering the ceiling and putting all these circles
Oh my,
into the ceiling.
pretty. So painted, rendered blockwork.
Pool area and entrance.
Mm.
Only is a great word. Use it all the time in the list.
I'm going to get a wriggle on. We're not going to get this finished. All right. So we've already discussed the floor structure. Who wants to say what that is made out of? Describe it as closely as you can in technical terms. The floor. Not jelly. Yeah.
Not jelly.
So let's go with the first thing. Then what's the most obvious thing that's going to be describing it? Concrete. Yes. Okay. Is it on the ground or is it up off the ground? Carport slab's on the ground, so it's...
Wait, above.
That's with an S. Suspended. Yes. It's being suspended. So we've got a concrete, suspended. What is it? Floor slab. Yeah. Yeah. But what specific type of slab is it? So, no, that'll be the finish. We'll come back to that. But the slab itself, remember there were a couple of different types of slabs in the notes? Let's see if I can get them out for you.
Is that like reinforcement?
It'll be reinforced, yep. What kind? How many amounts? If I could say it that way. Do you remember? It was earlier today. No, too soon for sections, unfortunately.
So is that like referring to like pre-stress?
Pre-stress could be an option, but we probably don't need that.
I know it's not pre-stress, I'm just like thinking in that area. I'm like, what?
A two-way slab is probably true, yeah.
Okay.
There's no cars on this floor, there's only apartments. No, and the ground floor supports the ground floor slab, so it doesn't need to be two-way. I'm just thinking, is it either a one-way or a two-way slab with the reinforcement? Have we got 2 rows of reinforcement or 1 row of reinforcement? Any suggestions about whether it should be a one-way or... No, this is upstairs, suspended, first floor.
We're on the first one.
Okay.
Because I'm looking at this plan and I'm thinking...
No,
sorry.
Yeah.
That sounds like, oh, in ground, on ground.
There's the elevations if you need. Yeah?
The wall is going to support the firewalls and also the into units.
Yeah. The heavyweight construction is quite substantial. The block work will be core filled. We've got more floors and more floors and more floors. So we're going to need at least a two-way slab. Now, what you don't have in this textbook is what will probably need to happen on this particular level is for the slab to be significantly deeper than the subsequent floors above that. Because you're changing the loads where you've got consistent layouts of blockwork, room layouts, one above the other, the load is consistent and can go through the slab and down to the next wall quite easily. But where you change from multiple floors with multiple rooms that are the same layout to columns, the transfer of loads needs to relocate down those columns. So the loads from upstairs have to be transferred into the columns. So we need a transfer slab at that point. So you're probably looking at a maybe 450 millimetre deep two-way slab in that instance.
So have a look at the floor plans where you see the blockwork above here. This blockwork is not lining up with these columns down here. So typically when you have blockwork construction, you need a blockwork wall underneath your floor to take the load straight down to the ground, that transfer of the load straight down. In this layout, because we've got a carport park on the ground level and unit apartments on the first floor level, they're not stacked on top of each other. So the slab has to do a lot of work. The load has to come down and then transfer out through the slab in a horizontal way, and then find the column and transfer down to the ground.
And that's why it's called a transfer slab. So it'll be thicker, more reinforcement, and it'll allow us to be flexible and different above and below it. So the first slab will be called a transfer slab, and I predict it'd probably be about 450 millimetres thick. But again, I'm predicting it's an engineer's specification. But it'll be a two-way slab, at least. Yep. Proposed, if you like. There's a chance that rather than being solid 450, it might be narrow it in some places and then have beams, or who knows?
So in the report, we make the party section and to make a sketch, something like that, put in the report. I mean, like sessions to show the structure.
If you can, that would be terrific, yeah. I would love that. What's going on the top of our transfer slab, which would just be painted and sealed? You would just see the edge of it, and then everything else would be on top. What's sitting on top of our
First floor level that
slab?
we're looking at here. We're into
Do we still have to put a membrane or like waterproofing coating?
We don't want the rain that hits the transom to run in underneath the blockwork and run up. So you would seal that slab and seal the walls and everything. Yep. What were we saying the walls are going to be made out of? They're structural. They're doing a lot of structural work. Yep. So we considered precast earlier in the day, didn't we? But we were talking about the intricacies of this design and how that would be extremely challenging for precast concrete. So the blockwork allows a lot more flexibility and ease in construction. So even though it perhaps might look exactly the same in the end, painted, nice clean finish, the actual construction techniques would definitely be suited to blockwork. So we talked about heights. If we were to have 2.7 high blockwork walls structurally, would that give us enough room for ceiling heights and still give us NCC compliant room heights where we needed them? We don't have any ducting because we've got separate aircon units. So we're not looking at, several hundred millimetres lost for ceiling space for ducted services. Is the wall height at 2.7 going to be sufficient, do you think?
If we use, like we talked about it earlier,
The bulkhead?
bathroom and kitchen.
2.1.
Yeah.
And the benefit of a repeated floor plan is all the wet areas are stacked above one another. So you can have drainage that can run directly down rather than having to move around and go across underneath the slab and reach a different direction.
But I really wanted light fitting in the middle of the living room.
Are you on down
Okay.
Well, downlights, yes please. Love downlights. Yeah. Yep.
We go down.
So you can have, how are we going to have a ceiling with downlights? We do want a ceiling lining.
Maybe you run the button along and then put the wood.
Yeah, plasterboard.
Plasterboard, and then, but I don't know how electricians can be able to, I mean, it's possible, I guess.
Yeah. So they can use channels between the battens, but they probably would be either battens that are very tall, so that short little batten's only 20 mil high, but you can get 60 and 80 mil battens, so they're the same shape, that top hat. They're quite successful, or you could use a light gauge purlin to create a battening for the ceiling. We just don't want to lose too much head height, do we? What's our lowest head height that's permitted for the NCC?
2.4.
2.4. But what about the
Ceiling fans.
fans? Yeah. So what do they have to be for the fans?
2.7.
2.7. You can, as long as the underside of the fan isn't any lower than 2.4, it'll probably be all right, but it might feel a bit weird. It's a bit low. So how much do you think we might lose in ceiling height with the battens and the services and the downlights?
100 mil.
So the lights might be about this deep, if you like, with the fins and the blades and then the recess that sits, and you've got the thickness of the, might be looking at maybe 150. Just kind of guessing at this point. Yeah.
That's why most buildings will see surface mounted light fitting. Downlights do take that extra.
They need a bit of room to breathe, so they're not, the old ones were really hot, but the LEDs are not generating a lot of heat.
Because I know there's plasterboards only like 10 mil thick.
10 at most, yeah.
It's not about the thickness of the plasterboard, it's about
No.
the batten
And then the
holding
batten,
it.
Yeah.
I think that battens are like 80 something.
Yeah, you can get
You can
60.
get whatever.
Yeah.
60 mil, 40 mil
Yep.
battens are quite common. Yeah.
Mm.
80 something.
So if we anticipate using 150 millimetres at the most, we're down to what, 25, 50? And the ceiling fans can be quite short little pedestals that they hang from, so that's not too bad.
What about raising the slab to give it a header?
I would do that.
Go a bit higher?
Or consult with the client to see if they want downlights or not.
So a note in the report will be that consideration for the height between the floor and the ceiling will be needed to determine by the amount of services and the ceiling height and the location of fans. I think it's achievable to have a 27 high wall height and still have services and fans and a compliant NCC.
So was that nice that you said?
I don't remember.
Ceiling height.
Now if we just stick to the main structure at this point, did we already note the walls? Reinforced concrete blockwork,
Yeah.
2700 high.
Yeah, okay.
Yeah. So it'll be 2.1 metre high headers. The head height will be 2.1 for the doors and windows. How many of the courses above the doors and windows do you think will be core filled in this instance? There are 3 courses above the doors and windows in a 2.7 metre high blockwork construction wall. We know that the one directly above the doors and windows needs to be core filled to be the lintel. How many of the others do you think will need to be core filled in this instance? I think they will, yeah. I think all 3 courses above the doors and windows will be core filled because it's quite a lot of work. And then of course don't forget to note that the core will be filled and reinforced adjacent to openings in the corners and 900 centres everywhere else. Except where we've got something important, special kind of wall on each floor. What have we got that's special? The NCC called for something unique in some walls.
The walls are between 2 units, or they call it
Yeah?
the separating wall.
Yeah? Somebody help him out? Andy? Can you help him out? What's special about this separating wall? Do you remember? No? Nicole? Any clues?
The FRL of 1999.
Yeah? Yeah? And the external walls that are between the two? Yeah? And the external walls that were within, remember we said they're most likely to be within 1.5 and 3 metres of the boundary, that fire source? So how can we achieve an FRL of 90-90-90 for the blockwork walls?
We are going with 200 blockwork, aren't we?
It'll need to be 200 wide to create that structural stability. And I was just talking about core filling for the whole down, but what could we also do if we wanted to create a fire-rated wall?
We can core fill that as well.
We could fill all the cores. So the fire walls, and you might want to highlight those on your drawings, the external perimeter walls, this perimeter here, and the centre line wall between the 2 units are all going to have to be firewalls, aren't they?
So in your report, have a drawing where you mark the firewalls.
Yeah.
Maybe in a different colour, just to mark it up on your floor plan. Identify the firewalls.
Doesn't mean that you have to put reinforcing in those cores, just the concrete. What about the lift shaft?
Mhm.
Correct. Make a note of that. Well done.
Typical floor slab. You know, between apartment to apartment, rather than the transfer.
Through that. Everybody okay? So we've got the transfer slab above the carport columns, and then we've got our first floor of blockwork walls to create the first set of units, and then we've got to put another slab on top of that. So what would that be called? Similar to the transfer but not transfer. How would we describe that? Yeah, you can see that coming through. How would we describe that structure if we had to tell somebody what we wanted? Nicole, did you want to have a go? So what's it made out of? What's it made out of? What's the composition of it? Concrete, and it's reinforced. Excellent. And is it precast or cast in situ? So it'll be a suspended slab rather than a precast slab. In situ means in situation, on site, so it's cast in situ. But it doesn't need to be as thick as the transfer slab. Does anybody want to offer an idea of how thick they might think this one needs to be?
Maybe 200.
Done. Sold. 200 millimetre thick, two-way, reinforced concrete, suspended slab. I predict. Again, engineering will have to confirm.
So you have to make a choice of how you think you're going to draw that to do the initial concept design drawing. So if we use these dimensions and that we're thinking about now, then the structural engineer will correct you when they're wrong. He's going to
Got to have something to start with, don't you?
have something to start with.
I think that's a fair suggestion. We don't want to give them too much, do we?
No.
Now we're going to repeat that same system. So that's this line here that Sandra pointed to. It's going to be exactly the same structural system above it, and then again, and above it, and then again for the roof. So it just keeps going up. It's repeated. That's the good thing about multi-storey complexes that are the same.
So
it's nice and quick to build.
This level is like a transfer slab. This slab will be the same as this slab. Then this one's going to change again. They've got a different purpose of the roof.
Do you think we get any thinner? Might not be two-way slab, might just be one, but I don't know necessarily that we get much thinner, do you?
The same, it maybe get slightly thicker to create a fall.
Oh yeah, good point.
Oh, for the roof. Okay.
Good. So this is a handy little view of the roof from the top down. Got these double lines here. What's that, do you think?
What's that called? That is called the
On the roof.
parapet wall.
You think it's a parapet wall? Yeah, well, it kind of is. It's sticking up, certainly. Do we have a bit of an indication of how far? On the elevation, you can just make it out there. Easy to see, but it's just above that top slab there.
Does it line up with the walls of the building below?
I think we said 3,000.
So we've got these little indents
Here's
here I
our-
can see for these little balconies
Mhm.
that seem to correspond with
Yeah.
these little indents here.
And there's the lift there, the stairs, and then it goes around. It goes directly down and across this one,
Across there.
but it does jut in, and then go around the balcony, up, and then this is the balcony here, so it's in and then back out, and then it goes across, yep, and then it just travels all the way up and around and back again.
It seems to follow the outline of the external walls of what is
Keeps
below.
those loads moving down, which is nice. It's not doing a huge amount of work. It
So if I
will,
was doing this in
Yeah.
software, I would overlay one plan on the other in the software, and then you can absolutely see. It's difficult like this. The other idea is that you could lay it on the white box, and one drawing would shine through the other, and you can
Yep.
see if they're actually lining up.
yeah. So we're perhaps looking at maybe, let's have a look. It's not a trafficable roof. What are we looking at? Perhaps a 600 or 800 high wall. So the balustrading has to be how high?
One meter.
No, 1.2 might be a bit excessive.
1 meter.
Just 1 metre, yeah. 1.2 for some
Industrial.
circumstances, though, yeah.
Industrial control.
The balustrading up on the upper balcony in the prison, the new prison, is 1.2. So if you get charged, you don't get tipped backwards over.
Oh, okay.
Yeah. So in dangerous circumstances, 1.2 is a good idea, but I think these are just 1 metre. So if that's 1 metre, in comparison, how high do you think the parapet wall might be? This is just, this bit popping up here is the top of the lift, so don't be too concerned about that.
That's at 600.
These are 600, these windows, by the looks of things too.
Mm.
It's not a trafficable area, so it's not, it's a parapet, not a balustrade.
Mm.
Yeah, I'm happy with 600 if you're happy with 600. But it would be a blockwork wall, perhaps rendered, and it would do what Sandra was saying, it gives some substantial thickness to the appearance of the site. So it's just a perimeter parapet, yeah, that's fair to say. And then what's all this stripy stuff?
The roof sheet.
Yeah, isn't it? Roof sheeting. So
We're going to go with like 200 mil thick roof.
we've got this, Sandra was talking about shading this concrete with a fly roof. This one's quite fancy, it's got 2 different pictures. So I should probably have it around this way, I suppose. Here's the short side, and this is the lift, and some screening off for the air conditioning areas. There's the short side, and then there's a big long side this way, isn't there? And then a gap between them. I wonder where the water goes. So what material would you recommend for the top of the fly roof? Andy, what do you reckon? What material should we give to the top of the fly roof?
Cladding. Cladding.
Cladding? What kind of cladding? What do you think? What should we make it out of?
Metal.
Oh, thanks.
So good.
We'll bring
So-
the Balinese style into
Some, and the first storm?
Yeah.
Oh, that does hold very quite well, Messler. So steel sheeting here? Yes, excellent. And what would we have to put that on to get it to stay there? What would we fix that metal cladding to?
You want just float up there on the
No, which we did,
Screw it to
yeah.
something.
Or purlins, these would be quite significant members, and they would go this way. So the sheeting has to go this way so the water runs down. Can't have a water feature. So water runs that way, as tempting as that might be. So the purlins have to go the other way. And then what supports the purlins? Okay. Walls, yeah. So we could do it a couple of different ways, but most likely we're going to have some columns and beams, aren't we? Yeah. So steel columns and beam construction with purlins and roof sheeting. And I expect it'll be a nice light colour because it's doing a lot of shade, and a dark colour defeats the purpose. And it would have to be in accordance with the deemed to comply manual, wouldn't it? What might we do with the wall part? Here we've got this elevation, if you like. We can't really see anything. Are we going to leave it open or are we going to fill it in? You think leave it open?
This,
on the other elevation there's some sheeting, isn't there? Yes, you're right. Horizontal sheeting. It does look good.
It's got a contrast on it.
Yeah, it does look good. So this would be a nice light colour. The roof would be a nice colour to keep shade. You could have a little bit of dark contrast under the shade there. It's going to be shadow anyway. How would you secure that horizontal sheeting? What would that get fixed to? So it's not structural, but it does need to be fixed to something. What do you think, Nicole?
I didn't hear what you said.
Mm-hmm.
I didn't hear what you said.
What do we have to fix the cladding to? We could just get somebody to go up there and hold it forever.
Yeah, magic.
Just hold it. Just stay there.
Could you get a magnetized system? Force field.
It has to be screw fixed to something. What could we screw fix that roof sheeting, the wall cladding to?
I think I am under nodding.
I know, I'm like, what are you trying to do? I don't understand.
Good.
No,
Oh,
because it's too far. There's a column here and maybe a column here and a column here. That might be too far for the girts. It could be girts, you're right. But maybe just some framing, infill. So Sandra talked the other day about cladding in a hole, fixing it in. It's not structural, it's just waterproofing and aesthetics. So you could perhaps put some framing in there, or some girts might do the trick too. Yeah. Excellent. So steel column and beam, purlin, roof sheeting, and either frame or girt fixing for the horizontal wall cladding of a contrasting colour. That looks very nice. Now we talked a bit about the phenomenon of very lightweight construction under wind loading, and this might be one of those instances where we might suffer some structural damage. It's very high up, the winds would be strong up there. What additional support could we offer the different crisscross of structural systems that we've got on this fly roof that might help hold it in place? Nicole looks like she wants to tell me. Go? Yeah? Yeah? Yep. Cross bracing. Well done. Excellent. So you might need some cross bracing both in the roof plane and in the wall plane. Excellent. Very well done, Nicole. Thank you. When purlins and girts have to stretch a long way between columns or between beams, you can often do mid-span bracing as well. So just make a note of mid-span bracing. It's a phenomenon where if you've got a number of purlins running, so I've got columns, beams, and then purlins running across them, but they can span a long way, purlins. They're quite good structurally, but you just want some extra support. You can just connect them together mid-span. So this is the span that they're reaching from beam to beam, and you just want a little bit of extra support in the mid-span. So that's
just offering
snazzy.
rigidity, stabilizing it. It doesn't, those purlins are not bearing. They're not bearing their load onto those. They're just offering.
Just keeping them from wobbling in the middle.
They're bearing onto the two main beams that are connected to the post.
But it's all still squares, and it can all just go like that easily enough. So the cross bracing will create that triangulation to keep it in place under wind loading.
It's the little structure of a matchstick or like a lollipop stick. You get the concept of bracing really well when you do that.
Or cards, playing cards.
Yeah.
Yeah. So the surface of the roof sheeting is called colour bond. It's like it's a trademark name of the way colour is applied to the roof sheeting by Lysart BlueScope. There are other companies that do it, but they also use the same proprietary system of ColourBond. And it's not a surface addition to the metal. It's actually impregnated at the cellular level into the steel process so that it's very difficult to lose. It doesn't flake off like a paint might. So it's a special finish, ColourBond finish, and it's spelt without the U. So colour without the U. It's just COLORBOND.
Again, I
ColourBond.
got this wrong for about 3 years. When I first came to Australia, I had to put a U in every time.
Yeah.
Got to check an AutoCAD or Revit. We'll also put the U in for you.
Yeah, it will. Yeah, just be careful of that. So it's important we get that correct. ColourBond. It's a terrific product. Lasts in our harsh conditions really, really well. If it's under friction, so if you have a tree branch or something constantly being pushed against it, it will wear away the top layer and you'll end up with just the bare metal underneath. But under normal circumstances, it's extremely hard wearing. All right, very good. Where are we up to?
So we kind of skipped over the actual roof slab.
Sorry, yes,
Yeah.
we did mention it very briefly.
Yeah.
So we'll need a suspended concrete reinforced roof slab as per engineer's specifications. And we might have to leave it there because it's 4 o'clock. Yeah.
So we said 250 millimeters for the roof slab.
250 sounds
A little
excellent.
bit extra.
And then you can afford to lose some on the fall.
Left fall.
So what I predict is happening is this half of the roof is fall to here and this half of the roof is fall to here, as are the roofs. And then you've got this opportunity to deal with the drainage in one area and it would be all sealed up underneath.
I just think, I'm looking at it, that area is corresponding with this
It is exactly.
area.
It is
Why
exactly.
they're doing that is, this is an external corridor, so what they're thinking is, so we bring all the water in there. If the worst case scenario happens that we have an overflow in a guttering system or something, it's only going to spill into an external area. It's not going to come into the apartment.
Very sensible.
Right, you mean this one?
Yeah, it lines up directly with that area. Yeah. Well done, everybody. We'll pick this up first thing tomorrow morning.
Would that also be like a acoustic thing? Because obviously the water's going to trickle down there and like...
It would go down the guttering.
Yeah.
Like they'll have down pipes in this location, perhaps.
Okay.
Yeah.
It's not going to follow directly
it's not.
the roof
Yeah.
line.
No.
Have you heard the rain and down?
Yeah.
Not much time for thinking.
No. You just turn the TV off and enjoy the show.